Hello everyone. So today we are gonna solve the question house robber. It's a pretty good question for a DP medium level. So the question says you are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed, and the only constraint stopping you from robbing each of them is that adjacent houses have security system connected and it will automatically contact the police if two adjacent houses were broken into same act. Now this is a very important line. It basically means that if one house gets robbed, then the and consecutively if the adjacent house also gets robbed, then the alarm system will know and our robbery will fail. So in simple words we can say that it means we cannot rob two adjacent houses at the same time. So now the question next says that given an integer nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. Basically they are saying that without stealing two adjacent houses we have to find the maximum number of money we can gather by robbing the houses. So let's start. So let's build the logic first. um, what will be the recursion tree for this? It will look something like this. Suppose so our logic will look something like that. Suppose we are in a index currently and we have two choices. Either we can rob it or we can skip it and next go to the next index. Now suppose if we choose to rob it, then we add it to our answer, that is we stole it, and our current nums of I is equals to plus solve nums of I plus 2. Basically what we are doing here, if we are robbing an index, then we are basically saving it and adding it to our nums of I and going to I plus 2, that is next to the adjacent, because we cannot go to the adjacent index. So still basically means we are robbing from that and jumping to the I plus 1th index. And suppose we decide to skip. So if we skip, then basically we are not robbing that place. So what choice do we have? Go to the next index, which basically means we jump to the I plus 1 index. Now we want our answer recursively to be the maximum, that is at each step of recursion we should choose the most maximum and optimal uh, house to rob. That's why we are returning here the max of steal and skip. We are basically trying to see that whether it is more optimal to skip the house or steal the house, and which is maximum, which is going to give us the maximum answer. We're gonna do that only. Therefore here we have written max of steal and skip. So let's write the code for it. So yeah, first I will try to do this with simple recursion. Now to this I am going to make a separate function called solve, because here we have to use I pointer to basically decide whether to steal or skip the house. So it's I think necessary for me to use another, because in this section we do not have access to the I, and if we try to do it, it will be more lengthy and not optimal. So I'm just gonna return uh, a function solve. Oh sorry, I had to write it like this, where we will pass our vector and where our I is going to start, that is 0 index. Okay, now I'll make my solve function and solve. What are the parameters I should pass here? It's vector and an integer I. So I can just copy a vector parameter here and I. So let's define the base condition first. What is the base condition? That if our index goes out of bound or out of array, then basically we cannot steal from that. It's just out of the bound, so we'll just return 0. So basically, so let's decide the int n is equals to nums of size, and if I is greater than equals to n, basically going out of bound, then we can just simply return 0. Now we will write the main logic here. So the main logic is, I'm gonna make two integers here, int steal and int skip. So what int steal means, that rob the current house and jump to the I plus 2th index, so which basically means our current house plus jump to I plus 2 index. What does skip means? That do not rob the current house and just jump to the next index. That means solve nums of I plus 1, and we can just return maximum of steal and skip. I believe this should do it. So let's try to run it. Okay, so it passes all the test case. So suppose if we were to submit it, then let's see, here we are seeing a time limit exceeded. So basically we all know that the time complexity of recursion is actually very high. It can go up to 2 k power n. So to reduce this, we are gonna use approach 2, that is recursion plus memoization. So let's do that. So for that, I think I should make here a vector, and I will call it dp of size n plus 1. Okay, I need to specify n plus 1 here also, and let's keep all as -1 here. All the value currently is -1. And now let's specify int n is equal to nums dot size. Okay, now so I need to include this dp in my solve function as well. So I'll just dp it, and here I'm just gonna add another parameter, a vector, and name it dp. Now the base case is as it is, and we are now gonna write the condition that what will happen actually if, so let's write it now. If dp of I is not equals to 1, which means that it has been seen before or its value has been assigned before, then we are just gonna return dp of I. Now next, I think I just need to save, and no, sorry, dp of I is equals to max of state. I think this will work. Let's see. Okay, so we are getting an error here that Okay, we have not passed an argument here, so we should pass TP here also. Here also. I think this should work now. Yeah, it works now. Previously it was showing that our time limit was exceeded because of the complexity of the recursion, but now I believe that we have done the memorization, and the time complexity has been reduced, so I think now the time complexity should be gone. Okay, let's see. Okay, it's gone now. So this was it for the recursion and memorization process. So next up we are gonna see a very, you could say it's new to me also, I was also having a trouble understanding this, the bottom to top approach. I would like to see it. So so its procedure is something like this. We make another vector called t, which has size n plus 1, and currently we assign all the values as empty. You can say, no, for explaining I'm just saying that we took an array of n plus 1. Now we need to make base cases for that, because in this approach, if you do not have base case approach, then it will be very problematic, because the next index could only be calculated using the first two indexes. So the base condition is actually t of 0 is 0, because initially we have robbed 0 houses, so first index should be always 0, and the first index should be the nums of 0. What does the nums of 0 means? The first element of the nums, that is here 1, and it could be anything 1 2 3, it depends on the error. So why do you think we took 1 as our first element? Because in future we are going to see that we will have either choice to choose current or to choose the previous one, that is the one here. So we will have the choice, and depending on the condition we're going to choose the correct ti. Now let's specify what each index and what the value inside index, that is t of I, actually means. So it means the maximum stolen money till house I. So normally what people would do is they will try to save I, the maximum of the previous two houses. No, it is actually, it actually stores the maximum of the robbing that have already been done, the maximum stolen money till house I. That is a very important uh, thing to notice here. Now now suppose, so let's take example for t. Suppose we are at I is equals to 2. Now what are the choices we have? We can either steal or we can either skip. So what does steal actually means? So as we studied in the recursion, that in steal we take the we rob the current house and jump to the I plus 2 house. Similarly to that, what it means is that we okay, so what it actually means is that suppose I is equals to 2 and we decide to steal it, then what does that actually mean? That means that we came from 0 and jumped to 2, because we can't go to 1. So it basically means that we came from 0 and jumped to 2. That's what uh, steal actually means here. That is why we write steal as nums of I minus 1. Why nums of I minus 1? Suppose this is I, then in terms of, because this is t not nums, here when we come to nums it's I is equals to 1, but here I is equals to 2. That's why we are doing nums of I minus 1 plus t of I plus I minus 2. What does I minus 2 stand for? It stands for the where did we jump from. We jump from 0 to 2, right? Because we cannot jump from 0 to 1 because adjacents are not allowed. So we jump from 0 to 2. That's what steal actually means. Now let's come to what does skip means. Skip basically means we are skipping the house. So what does skip means? So currently I is equals to 2, so we just came from the previous position to the next. We didn't steal anything. If I were to steal anything, then I would have to jump to a two position afterwards, but we are not stealing anything, so we are just shifting to the right. That is why we were in I2, so basically we jumped from I is equals to 1 to 2. That is why here it's written skip is equals to t of I minus 1. Now at the end, as we did in the last also, t of I is equals to maximum of skip and steal. That is choosing the most maximum and optimal uh, answer for this. Now let's code it up actually. uh, I'll just reset it. Yeah, so let's first uh, name the variables nums dot size nums, and our base condition, if n is equals to 1, return nums of 0. Now let's make our vector that is actually going to contain our answers, that is vector and dp n plus 1. I'm keeping the size n plus 1 here, and initially I think I'll just keep it 0 just to be safe, so just to make sure that it's empty. Now let's specify what does t actually means. It actually means that max stolen money till I. Now I'll just no we cannot just loop now. We have to actually initialize the base conditions first. So what were the base condition? That is at t is equals to at 0, that is we have not actually robbed anything now, it's just 0, and t is equals to 1 is nums of 0, that is we now have choice to jump or not. Now we can loop through it for int I is equals to 0, I less than n. No, it should not be I is equals to 0. Why? Because the first two characters have already been assigned. So I plus plus. So what was our logic here? If int steal means from where we have jumped from, so